Hi everybody, welcome to SMR Telugu Education. Next topic, write a program to find matrix multiplication. Matrix multiplication. Here I am taking the matrix elements 1, 2, 3, 4, 5. Six, 7, 8, 9. Once again 1, 2, 3, 4, 5, 6, 7, 7, 8, 9, 1, 2. So this is one matrix. The size is number of rows is 4 and number of columns is 5. This is 4 by 5 matrix. So another matrix 1, 2, 3, 4, 5. So this is another matrix. Number of rows is 5. And then number of columns is 5. And then number of columns is 5. 5 by 5 matrix. Here you have to calculate the multiplication of two matrices. So if you want to multiply two matrices, here this one is one matrix. Here I am taking M2. This one is another matrix M2. M1 matrix is number of rows is 4 and then number of columns is 5. Here the number of rows is second matrix is, here you have to enter number of rows of first matrix and number of columns of first matrix. Next you have to enter the number of rows of second matrix R2, then number of columns of second matrix. Here in mathematics one rule is there, the number of columns of first matrix, the number of columns of second matrix is equal to the number of rows of second matrix. The number of columns of first matrix is equal to number of columns of second matrix. This both should be equal. For suppose here the number of columns of first matrix is not equal to number of rows of second matrix, then matrix multiplication is not possible. For suppose here 4 by 3 and 2 by 3, at that time matrix multiplication is not possible. Here first you have to check the condition C1 and R2 both should be equal. First you have to check the condition. Up to this you have to write the code. F2 file name is matrix multiplication.c. Here I am write main. You have to take the input is two matrices of size integer. Matrix array name is M1 of size 4. Number of rows is 4. Number of columns is better to take number of columns 10. Then number of rows 10. So 10 by 10 matrix. M2 number of rows 10. Then number of columns is 10. Next here you have to take into number of rows of first matrix, number of columns of first matrix, number of rows of second matrix, number of columns of second matrix. Just to clear the screen, CLRS here. First you have to enter the user, ask the user to enter the number of rows and columns. Enter rows of first matrix. Have to scanf, scan that one, address of R1. So copy this code, control insert and then enter, shift insert. So enter columns of first matrix. Columns of first matrix C1, and then ask the end user to enter the number of rows of second matrix and the number of columns of the second matrix. Copy, control insert, shift insert. Enter the number of rows of second matrix R2, and then number of rows of columns of second matrix. C2. Here the condition is, here the number of columns of first matrix should be equal to the number of rows of second matrix. So both are not equal, then matrix multiplication is not possible. If number of rows, columns of first matrix C1 is not equal to number of rows of second matrix, both are not equal, then give some message printf /n, matrix multiplication not possible. Then go to end, semicolon, then control goes to this end label. Here I am giving end label. So up to this you have to run this code. Alt F9, yes, control F9. Enter the number of rows of first matrix is a, here I am giving 2. Number of columns of second matrix is 3. The number of rows of second matrix is some 4 and then 5. Number of columns of second matrix is 5. First condition 3 is not equal to 4. Yes, condition true. Then this code is executed. Matrix multiplication is not possible. Alt F5, matrix multiplication is not possible. first matrix and then give some space first T. Matrix multiplication is not possible. Next, we have to save this one. Okay, now here the number of columns is 5 and then number of rows is 5, then both are equal, then matrix multiplication is possible. You have to multiply this one. How to multiply? This rows, multiply this row with this column. This one is matrix, the number of rows. This one is 0, first, second, third. This is the columns. 0, 1, 2, 3, 4. So just 0, 0 element is 1. Similarly here, the number of rows, 0, 0, 1, 2, 3, 4. The number of columns is 0, 1, 2, 3, 4. So here you have to multiply the first row. So please remember the resultant matrix. Whenever you are multiply these two values, the resultant matrix the number of rows is equal to the number of rows of first matrix. The resultant matrix number of rows is equal to the number of rows of first matrix, and the number of columns is equal to second matrix columns C2. When I have to multiply these two values, multiply these two matrices, the resultant matrix M3 this one is M2, the resultant matrix M3 number of rows is equal to the number of rows of first matrix, and the number of columns is equal to the number of columns of the second matrix. So this one is 4, this resultant matrix is number of rows is 4, number of rows is 4, number of rows is 4 and number of columns is 5. This is 4 by 5 matrix. So the number of rows is 0, 1, 2, 3. Then number of columns is 0, 1, 2, 3, 4. First this element. How to get this element? How to get 0, 0 element? 0, 0 element is equal to 1 into 1 plus, you have to multiply this one. have to multiply this one into this one. 1 into 1 plus 2 into 1 plus 3 into 1 plus 4 into 1 plus 5 into 1. This result will be stored in the 0th element, M3 of 0 0. So here 1 into 1 plus 2 into 1 plus 3 into 1 plus 4 into 1 plus 5 into 1. Here what is 1? Here 1 is m1 of 0 0. Here we have to multiply m1 of 0 0 in this one element is m1 of m1 of 0 0 into this one is m2 of 0 0. Next one is plus next this 2 is m1 of 0 1 m1 of 0 1 into this 2 is m2 of 0 1. m2 of number of rows, first row is 1 and then 0. This element is m2 of this element is this one m2 of 1 0, m2 of 1 0. Next plus this one 3 into 1 this 3 is m1 of 0 2 into 1. This one is m2 of number of rows is 2 and then number of column is 0. This one value is m2 of 2 and 1, m2 of 2 1. This 3 value is m1 of 0 and 2. Plus next 4 into 1, 4 into 1. This 4 value is this one m1 of 1 3, m1 of 0 3 into this one m2 of number of row 3 0. m1 of 4 is 0 3 into m2 of this one is number of row 3 and then number of column is 0. plus 5 into 1, 5 into 1. This 5 is m1 of 1 5 into this one is m2 of 4 0. m1 of 0 4 into m2 of number of rows 4 into 0. This is sum. This is sum. You have to calculate this sum and write here. Okay. Yes, so please observe. This one is 0, this one is 0, this one is 1, this one is 1, this one is 2, this one is 2, 3, 3, 4, then 4. This is the first one is whenever this loop, in this loop this number of rows, third matrix M3 number of rows is equal to the number of rows of first matrix. R1 is the number of rows and resultant matrix M3 matrix number of columns is equal to the number of columns of second matrix R1 and C2. Now this is the outer loop. See, outer loop is number of rows 0, so number of rows is less than R1 R plus plus. This is the outer loop. If the number of rows is equal to 0 to 3. This is the number of rows. If the number of rows is equal to 0 to 3. Next, number of columns. This is outer loop. In the outer loop you have to write inner loop. Here the number of rows, number of columns is equal to 0. Number of columns less than or equal, here the number of columns of third matrix is equal to the number of columns of second matrix, that is C2 then C plus plus. Now this is the outer loop, this is the outer loop, this is the inner loop. Now we have to write one more loop to calculate this sum. So initially the the array default values is garbage values. Whenever we are declaring M3 matrix, the default value of 0 0 is garbage value. Next 0 1 is garbage value, 0 2 is garbage value, 0 3, all are garbage values. Here we have to multiply these two values, multiply this row with this column, then you have to add these values. So first you have to initialize the each element of matrix M3 is 0. Here you have to initialize M3 matrix of number of rows and number of columns is equal to 0. Now here observe, three, these are same, 4. Here you have to write one more loop called innermost loop. This is the outer loop, this is inner loop. The innermost loop, you have to write this one as a loop. So when this one loop is repeated first time, the sum is stored in M3 of 0. So please remember, here the addition is how many times? This one is one time, this one is second time, third time, fourth, and then fifth. So this addition, how many times addition is depends on this value, columns of first matrix and the rows of second matrix. This value should be equal. That means the innermost loop is repeated how many number of times? Either C1 or R2, both are same. So this loop is repeated the number of C1 or R1. Here you have to write. So here the innermost loop, the number of rows, starting value is fixed 0 up to 0 to how many times? This addition is 5 times. Here you have to write here I am taking t is equal to initial value is fixed t less than how many times? Either C1 or R2, both are same, so t plus plus. So here the starting value is 0. We have to multiply these two values, m1 of row and m2 of column. So first matrix number of rows, first matrix m1 number of row. That's why here you have to write m1 of r and m2 of column. This one is column. This 0 should be, here you have to write t. T starting value is 0. T starting value is 0. First time repeated, this sum is executed. Second time t value is 1. This sum is calculated. Innermost loop, third time is repeated. Then t value is 2. Next time t value is 3. Next t value is 4. Here you have to write this statement. So M3 of number of rows then column is equal to M3 of number of rows and column plus, so initial value is 0 plus 1 into 1. So how to write this one? You have to multiply m1 of number of rows, number of columns into m2 of number of rows and then number of columns. So this statement is very important. Here the first matrix m1 of number of rows and then m2 number of columns. Here the m1 here you have to write t, here you have to write t. Whenever this loop is repeated first time, so whenever this loop is repeated first time, you have to 1 into 1 1. So this value is 1. This loop is repeated second time, t value is incremented by 1. This one is calculated 2 into 1. Next, so this loop is repeated, t value is incremented by 2. Then this value is, this sum is added to this variable. Next, this loop is repeated third time. This one is calculated. This one is calculated. This sum is added to matrix. Next time, this sum is calculated and added to this variable. Whenever this t value is incremented by 1, this condition is failed. This one is out of the loop. Next, whenever the first time this one is executed, the sum is stored here. M3 of 0 0. Number of rows is 0. Number of columns is 0. So 1 into 1 1. One, 2, 3, 3 into 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15. First, next one is first row and then second column, calculated and stored here. Next element, first row and second column, stored here. First row and then next columns. Okay. So this is number of rows and number of columns. So this loop is for number of rows. This loop is for number of columns. Number of columns. This innermost loop is for to calculate sum. So calculate sum. So now we have to convert this one into our code. Here you have to ask the end user to enter the first matrix elements /n enter first matrix elements. For you have to take number of rows and number of columns, rows and columns. So first r is equal number of index starts from 0, r less than number of rows of first matrix, r plus plus. Here ask the end user to enter printf /n enter percentage row elements, first row, second row, third row elements. So first r value is 0, that's why here I am writing r plus 1. That means you have to first row second row, third row message. To scanf percentage d comma address of first matrix m1 number of rows are once again loop number of rows and then number of columns. For columns c is equal starts from 0, c less than c1 and then c plus plus. Now ask the end user to enter first column element. Printf /n enter percentage d column element. So first column, second column, third column up to then scanf percentage d comma address of m1 number of rows and then number of columns. This code is for scanning the first matrix elements. Copy, control insert, paste, shift insert. So printf /n enter second matrix elements. Second matrix elements, here the number of rows is 2. Enter here the number of columns is c2 and then scan the here is m2 of number of rows and m2 rows and columns. Now we have to logic for matrix multiplication. Matrix multiplication, here I am taking the number of rows of a result matrix. Result matrix number of rows is equal to the number of rows of first matrix and number of columns of result matrix is equal to the number of columns of second matrix. Here I am writing for third matrix you have to declare that matrix m3 of number of rows and then number of columns, taking r3 comma c3 variable declaration. So for this outer loop is for number of rows, r is equal to 0, r less than number of rows of r3, number of rows of result matrix is equal to number of rows of first matrix, number of columns of result matrix is equal to the number of columns of second matrix. So r less than r3, r plus plus. This is the outer loop for number of rows and then number of columns. Inner loop is for number of columns, c less than c2, c plus plus. Here you have to matrix for elements default value is garbage value, that's why here m3 of number of rows and number of columns initial value is 0. Here you have to write innermost loop for to calculate sum. So t is equal to 0, t less than that addition is equal to this addition is equal to the number of first matrix number of columns or second matrix number of rows, both are same. So this innermost loop is repeated either c1 or r2. So t plus plus. So how to write this sum? m3 of number of rows and then number of columns. You have to add m3 of number of rows or number of columns plus m1 into m2. Here m1 of number of rows, m2 of number of columns. It is the number of rows of first matrix is multiplied with number of columns of second matrix. That's why I had to write RC. Here to write T. You have to declare the variable T of type index. For index purpose you have to use of type int T F2. Save. Yes. So this is the logic for to write matrix multiplication. Next you have to print the result matrix. So for number of rows, r is equal to 0, r less than, first you give the some message, printf slash n result matrix is for number of rows, r is equal to 0, r less than r3, then r plus plus. For number of columns, c is equal to 0, c less than c3, then c plus plus. For every row, you have to enter printf slash n. So every time the control goes to next line, so print the values. Printf percentage is some space, comma m3 of number of rows and then number of columns. So F2 save. Yes. Now you have to run this code. Alt F9. You have to get errors. Here miss the parenthesis. Alt F9. Yes. One more. You have to copy paste maybe. So Alt F9. Yes. Control F9. Okay. So Control F. So first once again you have to run this code. You have to give in the same values. 4, 5, 5, 5. First element 1, 2, 3, 4, 5, 6, 7, 8, 9. Once again 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2. Now second matrix, first row, first column 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Here the first element is 15. Alt F5. Here the first element is the first element is 15. Enter. Okay. So this is the matrix multiplication. So Alt F9, yes, Control F9. So number of first matrix, number of rows is 2, number of columns is 2. Second matrix 2 by 2 matrix. The elements is 1, 0, 0, 1 or 0. Second matrix 1, 2, 3, 4. Alt F5. The result matrix is 1, 2, 1, 2. So here debug this code. So it will take time to debug. So please remember. So this is the matrix multiplication. So still you have any doubts, please refer once again. Thank you for watching. Bye.